Hi there. In this lesson, we're going to talk about how to solve exponential equations. So what makes an exponential equation an exponential equation? What makes it different? The term we're solving for is in the exponent. And what makes an equation is there's an equal sign in the middle. So we are solving for the exponent. And there's a couple different ways we can do this. We're going to look at a particular type of question today. And in these particular questions, all of them can be solved by using a technique where what we're going to do is make the bases the same on both sides of the equal sign. Okay? So if we do that, for example, if I have x to the power of a equals x to the power of b, if the bases are the same, then the exponents would also have to be the same for this to be equal. So let's show what we mean on some basic ones here to start. So I have 5 to the power of 3x minus 2 equals 25. Well, I can't really rewrite 5 as anything, but I can rewrite 25 as 5 squared. So look, let me just write this one down here. Notice how the bases are the same. They both have a base of 5. So for this to be the same, for the two sides of this to be equal, the exponents must also be equal. So the 3x minus 2 has to be equal to 2. So then generally what we do is we just say, okay, well, therefore, so we're going to basically create a new equation here, okay? We're done with this one. And what we do is this is going to be a new one. We take the exponents and we set them equal to each other. So I'm taking this and setting equal to this. So that's the thing we need to be clear about. This is like a new equation, okay? So it doesn't continue the same equation. So we're using this property right here, okay? If the bases are equal, then the exponents have to be equal. We make a new equation, okay? And then we solve that just like we would. So this is a regular old linear equation from grade 9 in elementary school, right? So we have 3x equals 2 plus 2, divide both sides by 3, and we get 4/3 as our answer. So x must be 4/3. So if we were to go back and we replace this with 4/3, right, the two sides would be equal to each other. 5 to the power of 3 times 4/3 minus 2 would equal 25. All right, so let's check out a few more here. Okay, this next one here looks very similar. Nothing we can do on the left side of the equation yet, so we'll just leave that as is. But obviously, we can rewrite 125 as base 5 with an exponent of 3. 5 times 5 times 5 is 125. Okay, now that the bases are the same, we can create a new equation and set the exponents equal to each other. So, therefore, what we can do here is go x squared plus 2x equals 3. Okay, so there's our new equation, right? Well, what kind of equation is this? This should look familiar to our previous unit. This is a quadratic equation that we learned a lot about in grade 9 and a lot in grade 10. Right, there we go. We can move everything to one side, and we have to make one of two choices when solving a quadratic equation. Don't forget, step 1, or option 1, you can try to factor it, right? Now, if it's easy to factor, I think this one here is going to be pretty easy to factor. That's usually the quickest way, right? If it's easy to factor. Option 2 is if it doesn't factor, use your quadratic formula. So let's just remember what that is, right? So if you're doing some of these and you're like, I can't get it to factor, even if you think it's easy and you still can't, you sub A, B, and C into the quadratic formula, and away you go, okay? Now this one's pretty easy to factor because we just need two numbers that multiply to equal -3. That add to equal +2, well, it has to be 1 and 3, and if we make the 1 negative and the 3 positive, it'll work. Little small detail here, this equals 0 should not disappear. That still has to be there. A lot of times people do this and then it just disappears, right? This thing is still equal to 0. Now we can break it down to two separate equations, which is x minus 1 has to equal 0 and x plus 3 has to equal 0. So we have two possible solutions here. X could equal 1 as one of our solutions, or if we subtract 3 from both sides, x equals -3. So again, pretty easy one, just some simple factoring there. Okay, let's check out, they're going to kind of each one go up a little bit in difficulty from the previous one. So the first one was linear in the exponents, the second one is quadratic in the exponents. Let's check out what's next. Okay, in this case we have a base 9 on the one side and a 27 on the other side. And we can't rewrite these, we can't rewrite 9 in terms of 27 or 27 in terms of 9, but we can rewrite them both in terms of 3, right? Because 3 squared is 9, right? And 3 to the 3 is 27. So what I'm going to do here is rewrite this as 3 squared, right? That's the 9. Now, so I put a bracket around it. The x plus 1's on the outside. Equals 3 to the power of 3. And then same thing, 3x minus 4. Now, what rule can we use here? We can use one of our power rules. Remember the power rule? When you have something to the power of something, you can multiply those two somethings, those two exponents, right? So what I can do here is I can multiply these exponents and multiply these exponents. For now, I'm just going to rewrite them like this. So I'm going to write it as 3 to x plus 1. So I am multiplying the exponents, and 3 to the power of 3 times 3x minus 4. Now, if you really want, you could just jump from here to there, right? But I'm just trying to show you clearly, step by step, what I'm doing, what the thought process is here, okay? So we have the same base. That's the main thing now, right? 3 and 3. So what we can do now is, therefore, we can create a new expression. 2x plus 1 has to be equal to 3 times 3x minus 4. So again, this is a new expression. I'm drawing this line just to make it clear that I've cut it off. I've started a new one. All right, so now this is another linear one with just some basic distribution to do. So 2 times x, 2 times 1, 3 times 3x, 3 times negative 4. Collect up all your terms on one side. I'm just going to leave the 9x here and subtract 2x. I'm going to leave the 2 here and add 12. I have 14 equals 7x. Divide both sides by 2, and I'm just going to flip it around. And I end up getting, divide both sides by 7, and we end up getting x equals 2. There's your solution. So another linear equation in the exponents, and we were able to solve pretty easily with some distributing. All right, so we've seen a basic linear one, we saw a quadratic one, we've seen one with a little extra work. Let's check out the next one. It's got some little hiccups that might throw you off. Okay, in this next case, what's the base that the x is on? Ask yourself that. Is the x on the 5? No, the x is only on the 1 over 8. So we need to get rid of that 5 out front. It needs to go. So what we need to do is divide both sides by 5. Divide this side by 5. Divide that side by 5. Because what we want to do is, like in the previous examples, we just had one base on each side, right? In the end, we had one base on each side. So now we're getting there. We have one base on each side now, right? Well, what can we rewrite 1 over 8 as? And what can we rewrite 4 as so that they have the same base? Well, 4 can be written as 2 squared, and 1 over 8 can be written as 1 over 2 to the 3, right? Now, they're not quite the same yet, because this is 1 over, and that's just 2. But what we can do here is, I'm not even sure why I have brackets here. We don't really need those, okay? Remember our negative exponent? We can rewrite this by moving it to the top and rewriting as a negative exponent. So that can be written as 2 to the negative 3, and 4 can be rewritten as 2 to the 2. So I'm going to come over here and do that. The 1 over 8 is now going to be 2 to the negative 3 to the power of x. And 4 is now 2 to the 2. Now, we can use our power of a power rule, right? I can multiply these two exponents together and just make it into 2 to the negative 3x equals 2 to the 2. So we need to get it down to one base on each side, and we want to make the bases the same. So whatever we're going for, we know they got to have the same number, right? And again, this 1 over 2 to the 3 does not have the same base as 2 to the 2, right? You have to rewrite it by moving that 2 to the 3 at the top and changing the exponent to a negative. All right, now we can cut this off. I'll just bring it over here and write our new equation. So therefore, if the bases are the same, the exponents have to be the same. Negative 3x has to equal 2, and this one is just going to be one step. Divide both sides by negative 3, and we get x equals negative 2/3. Make sure you move that negative out front. Never leave your negatives on the bottom if you want your work to be, respected and taken seriously. Just little details like that make a big difference in the eyes of others. All right, let's check out one final one for today. All right, so check this one out here. Look at all the different bases. What do we got here? 2, 4, 8, 64. Those can all be rewritten, right? Because 2 is just 2, right? 2 is 2 to the 1, so that doesn't need to be written. 4 can be written as 2 to the 2. 8 can be rewritten as 2 to the 3. And 64 can be written as 2 to the 6. So we can rewrite everything here as a base 2. So let's do that. So this guy we're going to leave alone. The first one is just going to stay 2 to the power of 3x plus 4. All right, the next one. We can rewrite that 4 as 2 to the power of 2. Now, to skip a step, I'm just going to write it like this. 2 to the power of 2, and then remember we can multiply the exponents. So times x minus 5. Okay? The next one, 2 to the 3. That's what we write 8 as. Times x minus 1. We're going to multiply exponents. And 64 can be written as 2 to the power of 6, right? And 6 times x, I mean, we could put a bracket like that, but we could just make it 6x if we want. All right, there we go. All right, so now what can I do? Because this is not one term, this is 3 terms over here, right? We have 3 of them. So I need to put these all together with one base, because we had to have one base equals the other base. So what we can do, we're multiplying, right? So what we can do is add all these exponents, right? When we're multiplying with the same base, 2, 2, 2, we can add the exponents. All right, so I'm just going to write it like this for now. 3x plus 4 plus 2 times x minus 5 plus 3 times x minus 1. So I've added all the exponents is equal to 2 to the 6x. Now look, we have one base, one base. The two sides are equal, the bases are equal. Therefore, the exponents have to be equal. So therefore, 3x plus 4 plus 2 times x minus 5 plus 3 times x minus 1 has to equal 6x. The rest of this is just easy distributing, simplifying, clean it up, away you go. So let's do that really quick here. I got 3x plus 4 plus 2x minus 10 plus 3x minus 3. And let's move that 6x over the side. Minus 6 equals 0. All right, I'm going to add up all my x's. 3, 4, 5, 6, 7, 8. 8 minus 6 gives me 2x, right? And I've got 4 minus 10. I'm at negative 6 minus 9. So I got negative 9. I'm going to move it to the other side and make it positive 9. Divide both sides by 2. There you go. X equals 9 halves. All right, so that's what we'd have to put into each x up here, right, to make these two sides equal to each other. That's the solution. All right, so there's 5 questions, kind of starting on the basics, getting a little bit difficult. Anything you work on is going to follow one of these patterns. So use these to help you through. Okay, take your notes that you need to and really try the questions out. Thanks for watching.